Hello everyone. In this video we're going to go over section 9.1 class note problems. So first question, we have a single card is drawn at random from a standard 52 card deck, and we're going to find a couple probabilities. So remember how this 52 card deck is. We have hearts, we have diamonds, we have spades, and we have clubs. And then the hearts and diamonds are reds, the spades and clubs are black. And each of the cards goes from the ace up to 10, and then we have the face cards, which are J, Q, and K. Okay, so now given that each suit has 13 cards, then we have 26 that are red, 26 that are black. Then we define probabilities depending of the type of card that we're getting. So for example, here, find each probability. The probability that a card is a black face card. Well, how many? Remember that we're gonna be using here the probability of the particular event as the number of times that event occur over the number of the total sample space. So in this scenario, this probability will be what? Well, the number of black face cards will be 6. We have JQK in spade, JQK in clubs, so we have 6 out of 52. And so that'll be simplified 3 out of 26. This is the way that we go over this type of card. The probability that a card is a 6. Well, how many 6 do we have? We have 1 6 in each of the suits, so we have 4 out of 52. The probability that a card is a heart. Notice that we have 13 hearts out of 52. So simplifying, this is like 1/4. Chances of getting what on one heart. The probability that the card is red in a 7. Notice that that is now red 7s. There are 2 of them, right? So there's 2 red 7s out of 52. So it's 2 out of 52, which will be 1/26. Okay. So that's the end of the first question. Now let's go to question number 2. So now this is about integers in a particular range. So remember we have formula that we use for that, which is n minus m plus 1, dependent of the numbers n and m. So from 0 to 1,000 inclusive, that'll be 1,000 minus 0 plus 1. And so that'll be 1,001 integers. Now from 3 to 20 inclusive will be, once again, 20 minus 3 plus 1, which will be 18 integers. Now from 27 to 85 inclusive, same thing, 85 minus 27 plus 1, this is going to be 59. From m to n inclusive, then n minus m plus 1, and that's it. Okay? We'll be using this later to calculate some probabilities of specific numbers in a range. For now, this is just practice. Now, number 3, we have a couple of dice. So we have blue die and gray die that are rolled together. And we want to write each outcome as blue or gray, right? And so first we want to use a compact pair notation to write the full sample space. We can write that as the sample space being the pairs I and J, right? Where I and J are numbers that belongs to 1, 2, 3, 4, 5, and 6. So this is a very compact way of writing that. Now, part B, or if we write this out once again in pairs, this is gonna be like 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and then 1, 6. And then we'll continue going down until we reach to 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So there's a total here of 36 elements. 6 in I, 6 in J. Okay. Now we want to use the set notation to write the event that the numbers showing up has some 6. So we essentially need that the blue dice plus the green dice are going to give me 6. And so the event, and I'm going to write it here as a set, well, how many combinations can give me 6? Like with 1, 5. With 2, I need 4. With 3, I need 3. Now with 4, I need 2. And with 5, I need 1. And of course, 6 cannot be involved because then I don't have a 0. So there won't be an opportunity for doing a 6. What is the probability of this event? So the probability of getting something that gives me some 6. Well, the event is giving me 5 different options. So this is 5 options out of 36, which is the total sample space. Okay? So that's that probability. So now let's go to question number 5. Question number 5 talks about, question number 4 first. So we have how many 3-digit integers from 100 to 9099 are divided by 5? What is the probability that a random chosen 3-digit number is divisible by 5? So if it's multiples from 5, this goes really from 100 to 9095, because that's the multiples of 5. 9099 is not really going to be is not going to be a multiple of 5. So to count that, I can do 9095 minus 100 and divide by 5, and that's gonna give me like the total of possible numbers that are, well, plus 1, right? Plus 1 because we're being inclusive. This is gonna give me the total of numbers that are divisible by 5. So this is 8095 divided by 5 plus 1, which is going to be 179 plus 1, so 180. So in general, divisible by 5, there's going to be 180 numbers. Now in total, between 9099 and 100, there is 9099 minus 100 plus 1, which is 900 3-digit integers. So if I want to look at the probability of 3-digit integers divisible by 5, I'll say that it's going to be 180, which is the total of numbers divisible by 5, divided by the total of numbers here, which is 900. So this is going to be like 1/5. That's the probability in there. Now, the one below is kind of the same thing. How many 3-digit integers of from 100 to 9099 are divisible by 3? We already have all the numbers from 100 to 9099, so we're not going to calculate this again. But we can calculate how many are the multiple digits of 3. So the first multiple digits of 3 is actually 102, which is 3 by 34. And then the last and the largest is, of course, 9099, which is 3 by 333. So we can calculate the count of how many those are by just doing the difference between this and this, between the number 34 and the 333 plus 1. And so that's going to give me 300. So with the total of 3 digits being 900, so the probability of the 3-digit integer divisible by 3 will be 300 out of 900, which will be 1/3. Okay. Notice that the key part here is that we should obtain who's the first divisible by 3 in this range and see it as a multiple of 3, and here the last number divisible by 3 and see it as a multiple of 3. Okay, so question number 6. Two die are rolled, describe the sample space, and the set describing the set, the event that the sum of both die is 5. So the sample space, we already got it here. And in this previous question, this is the sample space of numbers with two die. Now the probability of the event that's both dice sum 5 is a different event though, the one that we did before. So if we want to get sums to 5, we get 1, 4, we get 2, 3, and then we get 3, 2, and then we do 4, 1. So this is our event of sum of two dice giving me 5, and the probability of that event is of course going to be 4 out of 36 elements, which is 1/9 simplified. All right, to finish up this section, let's go with question 7 and 8. So we have a single dice roll, describe the sample space, define the event, define the event 8 that the result is even, and B, the result that is greater than 4. Write A intersection B and find the probability of A intersection B. Well, the sample space here is really simple. It's just 1, 2, 3, 4, 5, 6. It's a single die, right? The probability of greater than 4 is just going to be the number 5 and 6. And A, which are the even numbers, are going to be 2, 4, and 6. So what is A inter B? A inter B is just the intersection of these two, which is 6, which is both even and greater than 6. And so the probability of getting A inter B is the probability of really getting 6, which is just 1/6. Okay? Or the number of A inter B over the number of the sample space, which is 1 out of 6. Now, number 8 is going to be something that we're going to be introducing soon, which is the rule of inclusion-exclusion, but we're going to kind of cover a little bit here. It says a number chosen at random from integers 1 through 100, what is the probability that it is divisible by 4 or by 6? So we want to count, let's say, the set A4 of the numbers that are divisible by 4, or multiples of 4 in 1 to 100. Okay, and we're going to use the same notation for A6, multiples of 6 in 1 to 100. And we're going to have that this is really the floor of 100 divided by 4, which is going to be 25. And this is going to be the floor of 100 divided by 6, which is going to be 16. So now, if we're trying to count what is the possibility that is both multiples of 4 and multiples of 6 in 1 to 100, right? This is like the multiples of the least common multiple of 4 and 6, which is 12, by the way. So what are the multiples of 12? Well, this is going to be the floor of 100 by 12, which is 8. Okay? And so now the probability that is going to be divisible by either 4 or 6 is the probability of the union, right? So we're going to aim to find out what is the union. And the union can be found by finding initially what is the chances that is divisible by 4, divisible by 6, and then removing the common between them once. Because here we have the common twice, counted twice, so we're going to remove once what we have. So this is like 25 plus 16 minus 8, which is going to give me 33. So the probability here of this event of A4 union A6 will be 33 out of 100 total of numbers. Okay, so once again, where you're getting the count and over the sample space. Okay, so that is the end of the class notes exercise for section 9.1.